We're going to get into section 7.5 where we're going to be solving some exponential equations. So this lesson is mostly going to teach you how to look for compatible bases. So in an exponential equation, if you have the bases match, okay, so if you have something like, I'm just going to write an example here, but let's say we have a to the x equals a to the y. So if these match, then x equals y. Okay, so we can just jump to the exponents are equal to each other if the bases match. So in this case, x equals 5. So I don't have to do any solving there. Okay, in this case, my bases match. So again, I can jump to setting the exponents equal to each other to solve for x. So we have got 2x plus 1 equals 7. So 2x equals 6. So x equals 3. Okay, here my bases do not match. So this is kind of the look for compatible bases. So I want to look at these bases and say, is there another way I can rewrite so that they do match? So my helpful hint is always look at the smallest one. So I would like to rewrite it in terms of 3. So can I rewrite 9 using an exponential with a base of 3? And the answer is yeah, I can write it as 3 squared. So I'm going to rewrite this as 3 squared, and then this x is just being multiplied in there, okay? So now that these match, now I can set the exponents equal to each other. So I have x plus 4 equals 2x, so x is equal to 4. Okay, so let's try that here. So 27 and 9, so I can't, 9 to no nice power is 27, but they both share a common factor of 3. So I could rewrite 9 again as 3 squared, and 27 is 3 to the third. So 3 squared, if I write as this, it's multiplying whatever else is in the exponent. So I like to write it in parentheses so I don't forget that. And then 3 to the third, there. So then these now match. So I set the exponents equal. So I have 2x minus 8 and 3 times x minus 3. So we've got 16 minus 2x equals 3x minus 9. Add my 2x, so I've got, continue up here, we've got 5x, and then add 9 to 16, so x is equal to 5. Okay, here, again, common base, 4 and 1, so 1's kind of unique, right, because anything to the 0 power is 1, so I can make my base whatever I want and just write it to the 0 power. So I could rewrite this one as 4 to the 0. So now again that these match, this is equal to 0. So 2x plus 3 equals 0. 2x equals negative 3. So x is negative 3 halves. Okay, before I can set exponents equal to each other, their bases must be the same and it must be a single exponential term. So I need to combine these first using my exponent rules. So when I multiply powers that have the same base, I add the exponents. So 3m plus negative m is 2m. So here I have 2m equals negative 2m. This one's not very exciting. 4m equals 0, divide by 4. So m is 0 in this case. Okay? All right, this one, remember that fractions come from having negative exponents. So I'm going to combine over here, adding my exponents. So I've got 10 raised to the negative 2x. And then here, if I want to rewrite this using a base of 10, that's the same as 10 to the negative 1, right? Fractions use negative exponents. So now I can set negative 2x equal to negative 1. So x is equal to 1/2. Okay, this one is kind of the same thing. So I want to think about what do these numbers all have in common in terms of powers. So 6 to the third is equal to 216. So I want to rewrite these using bases of 6. Preferably not 1/6. So I'm going to, if I wanted to rewrite this as a 6, I need to use a negative exponent so that it flips. So if I want to rewrite it as 6 to some power, this is the same as 6 to the negative 3x plus 2. Okay? Then times, so 216 is 6 to the third. So we're rewriting that guy. And then this one is 6 to the third, but it ended up in the denominator, so it was really 6 to the negative third. Okay, so now I'm going to combine these guys. So let's see, this is negative 3x minus 2. This one is 9x. So if I combine those, I get 6 to the 6x minus 2. Right? So then I can set those equals. 6x minus 2 equals negative 3. Add 2. So x is equal to 1/6. Negative 1/6. All right. Okay, here I have 81, 243, and 3. So I know that 3 to the 4th is 81, and I'm guessing 3 to the 5th is 243. Yep, so we're going to rewrite those guys. Okay, so, and sorry, this one's kind of, let me zoom in maybe a hair here. You guys can see that a little bit better. There we go. Okay, so here, if I rewrite this as a base of 3, it's going to be 3 to the 4th. So we have 3n plus 2 over 3 to the 5th. So 3 to the 5th and then times negative n equals 3 to the 4th. So now they're all bases of 3. Okay, so I'm going to simplify here. So I have 3 to the 12n plus 8 over 3 to the negative 5n. So remember, my exponent rule with powers of the same base and I'm dividing is I'm subtracting. So this becomes 3 to the 12n plus 8 minus negative 5n equals 3 to the 4th. Okay, so here this becomes plus 12n plus 5n is 17n. So we have now 17n plus 8 equals 4. Subtract 8. So n is negative 4/17. Okay, last one here. Zoom back out just a hair because I feel like that's hard to look at. Okay, so this guy, 16, 64, 64, common base that they could all share is 4. 4 to the 2nd is 16. 4 to the 3rd is 64. So we have 4 squared, with the 4 still there, times 4 to the 3rd, and then 3 minus 3r, equals 4 to the 3rd. Add these guys, so I have 8, okay, let's do this. 8 plus 9 minus 9r. So my bases match. So here I have 17. So I have 17 minus 9r equals 3. Subtract 17. So r is 14/9. Okay, that is all our examples for today. Big theme again is trying to find common bases and then use your exponent rules from there. Once your bases match, you can set the exponents equal.